Welcome back to Lesson E2A1, where we discuss equations of lines in 2D space. And so far we talked about the scalar or Cartesian equation of a line. We mentioned that it can be expressed in either slope y-intercept form, y equals mx plus b, or standard form ax plus by plus c equals 0. And now we are going to shift to the vector equation of a line. So the vector equation of a line is described by using vectors. And for us to understand how to get the vector equation of a line to the vector equation of a line, we are going to take a look at how to draw a scalar line and a vector line. And by the way, these are not formal concepts, scalar and vector lines, but I'm just going to bring them close to each other to describe how we draw a line using a scalar equation and how we're going to draw a line by using vectors. So we can only understand the vector equation of a line if we understand where the line comes from, so how we build it based on vectors. So let's get started. So as an example for the scalar line, or drawing the line by using a scalar equation, I brought in y equals 2 over 3x plus 1, which is slope y-intercept form. Now recall that to draw the line, we're going to need a point and a direction. And it's easy to see in here in this case. So as a point here, we're going to use the y-intercept that is given from the equation, or the value of b, which in our case is 1. So we plot the point 1 in here. And for direction, we are going to use the slope, which is equal to 2 over 3. So starting from the y-intercept at 1, we apply the slope, so 2 rising 2 over 3, so running 3, stop here. And we connect the 2 points. And voila, we got the equation, or we got the graph of the line, so the equation, this equation's graph. Now, how do we draw a line using vectors? So what does it take? So in order to use vectors to draw a line, we're going to need a starting point. But in this case, since we're using vectors, we are going to call this a starting vector. The starting vector is some vector that we call r0 with coordinates x0, y0. So I'm going to draw a vector here that we are about to use as a starting vector. So let's make it nice and neat. And let's label it as well, vector r0. So for direction, we are going to use what we call the direction vector. And surprise, surprise, the direction vector, for some reason, is indicated by letter m. So direction vector m has the coordinates a and b. And in this case, I'm going to take this as a direction vector right here. Direction vector m. So to draw a line using these two vectors, so a starting and a direction vector, means that to draw a line from the head of vector r0 following the direction of vector m. So here we are at the head of vector 0. We're following the direction of vector m. And I will extend the line both ways. And this is what we call the line L. Now, in order to describe the line, we're going to look at it as a line that contains two specific points. The first specific point that we use is the head of vector r0, so our starting vector with coordinates x0 and y0. The second point that we use can be any point on the line. Recall that x and y can be any point on the line. And for example, I'm going to pick a point somewhere on this line, say this point here, the point P. If I call the head of vector r0 A, then I would say that the vector OP, which is this one right here, and by the way, Just to honor it, we're going to make it bright red so it stands out. So we'll say that vector OP equals, so let's take a look at the triangle. This is vector OP equals vector OA, which is vector R0, plus, and now this is the other vector we need to add, and I'm going to call this vector AP. So again, take a look at it. So vector OP, which is the vector that connects the origin of the Cartesian plane with any point on the line, would equal vector R0, which is our starting vector, plus this vector here, vector AP. So I want us to focus our attention on vector AP. Recall that vector AP is parallel to vector M. And if two vectors are parallel to each other, we say that they must be scalar multiples of each other, which means that it makes sense to say that vector AP is a scalar multiple of vector M. So a scalar multiple of vector M can be described as T multiplied vector M, where T is a number or a scalar. So let's now take another look at our equation. So we can say that vector OP equals vector R0 plus T times the direction vector M. So here goes vector OP, and we denote vector OP by letter R, lowercase r. So we are going to say that this line in here can be uniquely described as a line that passes through vector R0 and this point in here, which is the head of the vector R. So there is one and only one line that we can draw that can pass through the heads of vectors R0, which are our starting vector, and this particular point. So we are going to say that R equals R0 plus Tm, and we're going to take this even further. Remember that R can be anywhere on the line. So we're going to say that this point P here would have the coordinates x and y. So we're going to say that xy equals R0, which we said is x0, y0, and then plus t, which is just a scalar, multiplied by vector m, which is the direction vector. And the direction vector has the coordinates a and b. So what we see right here is the vector equation of a line. Now, the vector equation of a line tells us that we're able to draw a unique line if we know the coordinates x0, y0, and which is a starting point, and follow the direction of vector m with coordinates a, b. Or we can draw the line by knowing the coordinates of x0, y0, and the coordinates of x and y, which are the heads of two vectors on the line L. So similar to what we said when we were drawing the equations, when we were drawing the graphs of equations of scalar, of equations in scalar form, then we are learning, or we are drawing the equations in vector form. So in scalar form again, we could draw the line by using 2 points. So we can use the two heads of vectors r0 and vector r. Or we can use a point, we said, and the slope, which means we can use a starting vector and a direction vector that can lead us to drawing the line. So based on the vector equation of a line, we can create the parametric equations. So what are parametric equations? Parametric equations, actually, first we're going to start with the word parameter. So the word parametric comes from the word parameter. So if we are asked to find the coordinates, or if we're asked to identify the coordinates of a point, so we can either say, what are the coordinates of the point P? You can say, well, the coordinates are x or y. Or you can ask, what are the parameters of point P? And the answer is the same, x and y. So parameters or coordinates means the same thing. So to write the parametric equations means to express the coordinates x and y in terms of x0, y0, a, and b. So we're going to say that x equals x0 plus t times a, and y equals y0 plus t times b. So these two are what we call the parametric equations of a line. So vector and parametric.